Good afternoon, dear students. Yes. Okay. So yesterday's class we have seen the laws of Faraday's, right? So we have seen the first law of Faraday's and second of Faraday's, that is law of electrolysis, right? So today we are going to start with the next concept, that is batteries. Okay, we are going to discuss about what? We are going to discuss about batteries. Now, what are these batteries? Yes. What is a battery? Okay. So battery is what? It is a arrangement of one or more electrochemical cell. Okay. What is a battery? A battery is a arrangement of one or more electrochemical cell. Okay. Now, that is, and these electrochemical cells, these are connected in what? These are connected in series. How they are connected? They are connected in series. Okay. They are connected in series. So, so these batteries, okay, so this battery or the cell, what it does, it converts your chemical energy into electrical energy. What it converts your chemical energy into electrical energy. And what type of reaction takes place? It undergoes a redox reaction. Okay, it undergoes a redox reaction. Now what do you mean by redox reaction? So redox reactions are those reactions in which simultaneously oxidation and reduction takes place, right? So what is a battery? It is nothing but arrangement of cells, okay, one or more electrochemical cells. So these electrochemical cells, how they are arranged? They are arranged in a series, okay. So thus this battery or a cell, what it does, it converts your chemical energy. Okay. So the cell, it is composed of what? It's composed of some chemicals. So this chemical energy, it is converted into the electrical energy and it undergoes a redox reaction. Redox reaction means simultaneous, there will be oxidation and reduction taking place. Okay. Now, next is, so battery, we are calling it as a battery or a cell. Now, battery and cell is same. Okay. Now, batteries, for example, the batteries can be your, what you know, now in the remotes. Okay. In the remote, either remote, you put this batteries. I'll show you just a second. So if you can see these batteries, right? So these batteries, which you can see, right? So these, you call it battery also, you call this what? You call it cell also, right? So these are the batteries or it is called as cell. So the word is same. Now, for example, in your this what vehicle, okay, for the engine to work, for the electric this to start, okay. So there is a equipment of batteries. So batteries are there also, right? So battery and cell is one only. Okay, only thing that what you say, types of batteries will be different. Okay, the battery which we are making use in toys, okay, in your remote control, that is different, and the battery which we are making use in the this what some storage, okay, for so some batteries, what you can charge first, okay, first you can charge, and once you okay, whenever there is what you say, a requirement of light and all, so that time you on it like that only, so it will give you the light. Okay, so later, so what it will do, whatever you have charged, it will start to discharge, right? And later again you can charge. So that is another type of battery. So batteries and cell are same. Okay, only you can call it as battery, also you can call it as cell. So that is same. So what are these batteries? So batteries are nothing but these are the chemical, that is it is a source of electrical energy, right? Now you know some batteries, okay, so which the torches, right? So some torches, they require such type of batteries. Okay, that is the cells which I showed you just now, right? So such types of cells it requires for those batteries. Okay, so that time what, with the help of this, what will happen? Whatever the chemical energy is there, that is converted into your electrical energy. And now some of the batteries, okay, first you have to charge those battery, and later when the light goes, so that time when you on it, so those are different type of batteries. Okay, so these are the source of electrical energy, and they can be more than okay, they have more than cells connected in the series. Okay, a good quality battery should be reasonably light. So whenever you're taking some battery, so if you're taking a good quality battery, then it's what you can say, it is the weight. Okay, the weight is very light. Okay, it is compact. Compact means you can easily carry it, and its voltage should not vary appreciably during its use. So inverters and all. So these are all batteries. Okay, now it is very easy to compact. Okay, there should be no other this. Okay, means when you are using it in the home, okay, no some hazardous thing should happen, right? All the care should be taken. So like that, the battery should be in the good quality. So it should be it is very light, it is compact, and it's voltage. So if there is any voltage fluctuation, okay, that battery should not get any hamper. Okay, so like that. So this is the batteries. Now these batteries are of two types. Okay, so the types of batteries are, or the cells. Okay, they are of two types. So primary battery and the secondary battery. Now what do you mean by primary battery? Okay, first we'll see what do you mean by the primary battery. So in this primary batteries, whatever the cell reaction occurs, it occurs only once and after use over a period of time. So the battery will become dead and cannot be reused again. Right. So what is that primary batteries? So the batteries which we make use on what? The batteries which we mm, so the batteries which we make use in the your remote controls, toys, right? Electric toys and all. So the batteries which we make use of. So what will happen? So till the chemical energy is there, okay, that much the battery will be used. Once all the chemical energy, okay, whatever the chemical present in the battery, if gets over, what will happen if it is used completely? Then the battery will become dead. Okay, and it cannot be used again. So what is the example? So the example is dry cell or Lecanque cell, or the second is mercury cell. Okay, so these batteries, they occurs only one after a period of time. This battery becomes dead. Okay, and these batteries cannot be charged. You cannot reuse them, or you cannot recharge them. Okay, what? These batteries cannot be recharged, or it cannot be reused. Okay, so this is about primary battery. What is secondary battery? Yes, what is secondary battery? So these are these in the secondary battery, after its use, it can be recharged. Okay, so once the whatever the energy, okay, if you're using from the battery, okay, once it gets discharged, again you can charge back. How you can charge it back? By applying current. Okay, so by applying current through it in the opposite direction, so this battery, secondary batteries, can be reused again. So secondary batteries are reusable. Okay, it can be used again and again. So secondary batteries or the secondary cells, okay. So these can be, what it can be done, it can be reused again. Okay, so these batteries, it can be reused again. Okay. So secondary batteries, as we are discussing about secondary batteries, so these can be reused again and again. Okay, so how you can reuse? By applying the electric current in the opposite direction. And these secondary batteries, these are also called as what? These are called as the storage batteries. Okay, you can call them as what? You can call it as a storage batteries. Why? Because you are using the electrical energy, and this electrical energy, it can be stored. Okay, whatever the electric energy is there, it is stored, and how it is stored? In the form of chemical energy. So what are the two types of secondary batteries? So please remember the example. So primary batteries, okay, once the cell reaction occurs, okay, the cell reaction, it occurs only at once, and after a period of time, what will happen? The battery will become dead, and these cannot be recharged and they cannot be reused. Okay, so what are the examples? Dry cells, and dry cell is one example, and second is a mercury cell. Secondary batteries, okay, so this once it is discharged, you can recharge the batteries. Okay, how you can recharge the batteries? By connecting it through the current, okay, in the opposite direction, okay, so that it can be reused again. So these batteries can be reused again. These are called as what? These are called as the storage batteries. Okay, these are called as the storage batteries. Okay, and what is the example? Lead storage battery and nickel cadmium cell. Okay, so these are the two types, two cells. So let us see some examples now. So very important. First is some, so these are used commercially, right? Commercially means now in toys and all. We use these batteries, right? Or it is also called. So here the first one is the dry cell. First one is the dry cell. So you can see this. So you have seen this regular batteries, right? You have seen this batteries. So these, okay, so these batteries, you have seen it regularly, right? So these, you see it regularly. So these, how it is inside, okay, you can see the top as well as you can see the bottom. So these batteries, okay, how it will be inside. So you can see here, it is given in the diagram. You can see in the diagram side, right? So how it is inside. So see, so this is a positive terminal at the above, and below is the negative terminal. So this is a positive terminal, this is a negative terminal. Okay, now you can see there is a red color surface, right? First is a red color surface. So that if you have a battery in your house, okay, you can take the remote battery and all. So the first coating, what it will be having? It will be having a metal coating. What coating it will have? It will have a metal coating. Okay, it will have a metal coating. So this is a metal coating which is there at the top, red color one. Okay, inside that, okay, just inside that, okay, what you have? You have a zinc can. You have a zinc can, which is a anode. Okay, which is a anode. Then here the gray color here you can see. So this is a insulator. Okay, it is a insulator. So it is acting as a insulator. Then inside this one, gray color, that is a graphite rod, and this graphite rod is a cathode. Okay, then in between the rod and the insulator you have this space. So here the paste of MnO2, ZnCl2 and ammonium chloride and carbon is placed here. Okay, then you can see this space, gray color space. So here what is there? It is a asphalt seal. Okay, so it is sealed here. Then above that you have some space, that is the air space is there, and here there is a porous paper. Okay, here you have a porous paper. So these this is the diagram. Okay, how it is represented. So this is the your cell. Okay, this is your dry cell. So dry cell, so how it is, okay, inside how the parts are present, what all is filled inside. Okay, so what are the different chemicals, okay, electrolyte and the different, what you say, cathode anode reactions. So that we are seeing now. So what is a cathode? Cathode is a graphite rod. What is an anode? Zinc. Okay, zinc can is there, and this zinc can, it acts as a anode. Now, so what it consists of? So this dry cell, what it is consist of? So important for 3 marks. Okay, dry cell important for 3 marks. Explain the construction and working of dry cell. Please note it down. Explain the working and construction, or construction and working of dry cell for 3 marks. So this diagram you have to explain. Okay, you have to explain the diagram and you have to give the construction. Okay, and you have to explain the cell reaction. So let us see. Okay, so let us see here. Okay. So here, what it consists of? It consists of a dry cell. You can see. So this is a cylindrical zinc. So it consists of a cylindrical zinc container. So there is a cylindrical shape. Okay, it is having a cylindrical. Cylindrical means like this. Okay, so this is a cylindrical shape. So it consists of this zinc can. Okay, so zinc can is there. cylindrically. And then what it consists, so this zinc, it acts as what? It acts as a anode. So the zinc is acting as a what? It is acting as a anode. Okay. And there is a graphite rod. So this is a graphite rod. And this graphite rod, what it does, it acts as a, it acts as what? It acts as a cathode. Okay, graphite rod, it acts as a cathode. So graphite is nothing but it is allotrope of carbon. So I'll write it as C. Okay. And this graphite rod, where it is placed at the center, right? It is center. Okay. Now this rod, what it is surrounded by? It is surrounded by a paste. Okay. It is surrounded by a paste, and this paste is of MnO2. Okay. MnO2 plus ZnCl2 plus ammonium chloride plus carbon. Okay, that is carbon black and carbon black. So this is a paste. Okay, it is made up of MnO2, ZnCl2, NH4Cl, and carbon black. So the space, so whatever the space is there in between, okay, you can see between the electrodes, it is filled with the, so here, so what is present? So the paste is there. So after this paste, okay, this whatever the ammonium, this is the ammonium chloride and ZnCl2. So that is pasted. Okay, so that is there here. So the space between these electrodes, how it is filled? It is filled with the moist paste of ammonium chloride and ZnCl2. So this is the your cell construction. Okay, this is your cell construction. So zinc is a cathode. Sorry, zinc is anode. Okay, the cylindrical shape. So that is a zinc can. Okay, it is acting as an anode. Then in the center you have the graphite rod. Okay, which is acting as a cathode. Then next to the graphite, okay, you have a paste of MnO2 and ZnCl2. And the gaps of this electrode, it is filled with ammonium chloride and carbon black. Okay, now we'll write the cell reaction. Let us see the cell reaction. So the cell reaction. So what is the cell reaction? At cathode and at anode. So at anode, what is at anode? So at anode, what is present? Zinc is present. So anode, what will undergo? It will undergo oxidation. Okay, at anode, oxidation takes place because it is an electrochemical cell. So in electrochemical cell, at anode, what happens? Oxidation takes place. So Zn gives you Zn plus 2 electrons. Okay, so Zn is solid. This is aqueous. Now at cathode. Now at cathode, what is the reaction occurring? At cathode, reduction takes place. Okay. Now here, what is present? Your ammonium is there. Okay, ammonium chloride, ZnC, that is ZnCl2. Okay, so these all this space is present. Then you have what? MnO2 is there. So at cathode, your ammonium chloride. Okay, so you have ammonium ions. Okay, ammonium ions plus you have MnO2 plus these two electrons from the oxidation is taken, and you get MnOOH, okay, solid, plus NH3, okay, plus NH3. So what will be the overall reaction? So write the overall reaction now. The overall reaction is Zn solid plus 2 NH4 plus, yes, plus 2 MnO2, giving you Zn plus 2 plus 2 MnOOH plus 2 NH3. Okay, so two electron get cancelled. So rest all we are writing in the overall reaction. So this is my overall cell reaction. Very important. Okay, so you need to know the cathode reaction, you need to know the anode reaction, and you need to know the overall cell reaction. Is it clear? So what is happening in this reaction? In this reaction at cathode, Mn. Okay, Mn is reduced from Mn plus 4. You can see Mn is in plus 4 state to Mn plus 3. So it is reduced from plus 4 to plus 3. And NH3 is produced. Okay, ammonia is produced. Whatever the ammonia is produced here, it will react with what? It will react with the Zn plus 2 ions. right? In the reaction, what is present? Again, Zn plus 2 ions are present. So this ammonia, it reacts with the Zn plus 2 ions and it forms what? It forms Zn NH3 4, okay, 2 plus. So this particular complex is formed and this complex is a soluble complex, okay. So what is the cell potential of this cell? Okay, that is your dry cell. It is 1.5 volts. Okay, so what is the cell potential? The cell potential is 1.5 volts. Okay, so this is a working and construction of your this. What is the uses? Where it is used? It is used in the clocks. Okay, it is used in the torch. It is used in calculators. It is used in flashlights. Okay, it is used in transistors. Okay, transistors. So these are the uses of dry cell. Is it clear up to dry cell? Yes, is it clear? So very important. Ask for 3 marks. Okay, what explain the working and construction of dry cell. Okay, so what all you need to write? You need to explain the diagram. Then you have to know what is anode, what is cathode. Okay, what is the electrolyte. Then you have to write the cathodic reaction. You have to write the anodic reaction, overall reaction. Okay, and what are the uses? So this is about the dry cell. Next is a mercury cell. So where you have seen this type of cell, you have an image here, right? You can see an image there. So where you have seen this type of cell? Where you have seen this type of cell? Yes? Okay. Watch, calculator. Yes, very good. Okay. So in your small wrist watches, okay, not the clock watches, in the this wrist, okay, where you put your this watch, right? So that then calculators, okay, simple calculator, then scientific calculator. So there, what you put the okay, you put use this what you use this type of cells. Okay, so this type of cell, it is called as mercury cell. What it is called as? Mercury cell. So you can see how it is there inside the cell. Okay, so here you can see red, yellow and blue. It is not red, yellow and blue. Okay, it just representation to show the different levels. Okay, now here you can see this is a metal body. What you can see above, okay, like a steel like body. So this is an anode cap. This is a anode cap. Okay, so this is an anode cap. Then just below this anode cap is your anode. Okay, and this anode, what it consists of? It consists of zinc amalgam. Okay, it consists of zinc amalgam. That is a paste of zinc amalgam. Okay, so paste of means it is a not paste. You can say zinc amalgam is there. Okay, it is acting. It is uh, over the after the metal this you have a zinc, okay, all over that layer. So then you have a, so this red color, it represents your anode, okay, that is zinc amalgam. Then here the space is there here, right? It is called as gasket. Okay, it's called as gasket. Then in between the anode and cathode, there is a separator. Okay, yellow color, it is a separator is there. Then your cathode is there. Okay, that is your cathode. Cathode consists of paste of HgO. Okay, mercurous chloride plus copper. That is carbon. Okay, so this is about your mercury cell. Okay, so this is about your mercury cell. So what does mercury cell consist of? It consists of a zinc amalgam paste. It consists of zinc amalgam. Okay, it consists of zinc amalgam. Okay, it acts as an anode. It acts as anode and a paste of paste of HgO plus carbon. Okay, it acts as a cathode. Then what is the electrolyte? The electrolyte is a paste of KOH and ZNO. So there is a presence of electrolyte. Electrolyte is what? Electrolyte is your KOH and ZNO. Okay, that is zinc oxide. Fine. So this is the what you can say construction. Okay. Now what is there? If I represent it in a box like this, okay, if I take one vertical side, so you have anode here, you have an anode which is consists of zinc amalgam. Okay. Then you have what? First layer is your, so that is only your anode. Okay. Next is your separator. So there is a separator. So this is your separator. Then you have your cathode, that is mercury plus carbon. Okay. So like this is your what? Your mercury cell. Okay. So the what is the electrolytic reaction? So let us see the reactions now. So at cathode, at anode, we have understood. Now let us see the cell reaction. So at anode, what is present? At anode, what is there? Zinc amalgam is there. So zinc amalgam ZnHg, okay, plus 2OH minus, giving you ZnO solid plus H2O plus 2 electrons. Okay. Then cathode reaction. At cathode, what is that? HgO. Okay. It will react with the water plus 2 electron, giving you HgL plus 2 OH minus. So this is the reaction. Now what all will cancel? Just see what all. So when you are now need to write the overall cell reaction. So your 2OH minus 2OH minus 2 electrons and water H2O H2O. So let us write. So it will be ZnHg plus ZnO solid. Okay, giving you Hg2 HgO plus just a second. ZnHg plus HgO, giving you HgL plus ZnO solid. Okay. So this is the overall cell reaction. Okay. This is the overall cell potential. What is the cell potential? It is approximately 1.35 volts. So the cell potential of mercury cell is 1.35 and this remains constant. So the cell potential, it remains constant because overall reaction, okay, it does not involve any ions in the solution. Okay, and the concentration will not change during its lifetime. So because any ion, because the overall reaction when it is taking place, so there no any ions can alter the concentration. Okay, so because of that, the cell potential will remain same because of CL. You can read this. So cell potential is constant during its life as the overall cell reaction does not involve any ion in solution whose concentration does not change during its lifetime. Now, where it is used? It is used in low current devices. Okay, like your watch. Okay, in watches, in calculators, and hearing aids. So some people cannot hear through their ears, right? So they use a instrument. Okay, they use one machine to so that they can hear properly. So in that hearing aid, okay, that machine, so these type of battery cells are used. Okay. So this is a mercury cell. Understood? So okay, important. So you need to know the diagram. That is a structural representation. Then you need to write the construction and working. Okay. So next we are going to see the example for a secondary battery. Okay, lead storage battery. So the secondary type of battery is the lead storage battery. So this, here you can see the diagram, right? You can see the representation of the secondary batteries. So how the batteries are arranged, right? They are packed. So these are the lead plates. Okay, these are the lead plates. Yes, okay. So these are the lead plates, and these are how they are yeah, vertically how they have arranged, right? They have arranged it vertically, right? So here, what it consists of? It consists of electrodes. Okay, it consists of electrodes, and these electrodes, these are the lead electrodes. That is your lead grids. Okay, like film. Okay, how they are? So these are the lead grids. Okay, one, two, three. So how they are arranged? See, right? So like thin paper, thin sheets. Okay, so they are made up of these lead. So the electrode. So this is a lead electrode, and in between this, okay, in between this, the anode grid. Okay, the anode is what? It is filled with your PbO2. It is filled with PbO2, and you have 38% solution of H2SO4. And what is filled? 38% H2SO4 solution is filled here. Okay, in this container. Okay, in this container, overall, what is filled? 38% H2SO4 is filled, and this is acting as a electrolyte. It is acting as a what? It is acting as a electrolyte. And this battery, how it is covered? It is covered by a plastic container. Okay, it is covered, or it is put into a plastic container. So so what are the reactions? Let us see. So what all is happening here? So the lead film like grids are there. So these lead are the electrodes. Okay, they are arranged vertically. Then in between, what is filled? PbO2. Okay, that is the uh, cathode. It is a PbO2. Okay, and then what is there? So the cathode, it is filled with PbO2. Okay, and there is a solution of 38% H2SO4, which is acting as a electrolyte. Okay, and this is put into the plastic container. Okay, it is put into the plastic container, and let us see what are the cell reactions. So here the cell reactions are given. Okay, so anode reaction, Pb solid plus SO4 minus 2 gives you PbSO4 plus 2 electron. So your anode is what? Your anode is the lead, right? So lead, and so this lead will combine with the sulfate to give you lead sulfate plus 2 electrons. So your oxidation takes place because there is loss of electron. Then cathode reaction, the spongy PbO2 is filled, okay, in between the grids. So this PbO2, it will take up the 4H plus ions from the this electrolyte, that is a 38% H2SO4 is there, right? So from there H plus ions are taken, and whatever the sulfate is produced, so that is taken, okay, and 2 electrons, and it forms PbSO4 plus 2 H2. So overall net reaction, so this and this get cancelled, okay, then PbSO4, PbO2, 4H plus, giving you PbSO4 plus 2 H2O. So what happens? What happens? Okay, on charging, okay, on charging, the battery reaction is reversed. So when you are charging, the battery reaction is reversed, and the PbSO4 on the anode and cathode is converted into spongy Pb and PbSO4. So as you are getting your PbO2 and Pb, so this is the your anode, this is your cathode. So when you are charging, what will so it will discharge, right? It will discharge. Then again, when you are putting to charge, what will happen? It will be converted into again to the lead and its PbO2, so this paste of PbO2. Okay, so reverse reaction takes place because you are discharging, you are charging back. So again, you get back the initial reaction. So again, discharge. Again, when you charge, again you will get back the spongy lead and PbO2 respectively. Okay. So at each electrode pair, okay, at each electrode pair, what is the voltage applied? Okay, the voltage developed is 2 volts. So the voltage developed is how much? It is 2 volts. Okay. So 2 volts are voltage is applied. So important, one more important reaction. So this is very important. Lead storage battery is also important. So you need to know what is anode, what is cathode, what is the electrolyte solution. Working and construction is very, very important. Okay. So where it is used? Okay, let us see the uses. So it is used in automobiles. Okay, these types of batteries, they are put into the automobiles. They are used in inverters. So in home, when okay, some of the people they put inverters, means when the lights are gone. Okay, so these inverters will be switched on and they will give you light. Okay, so inverters, then emergency power supply, right? So this all in this what we are making use of lead storage batteries. Okay, so lead storage batteries are making we make use of lead storage batteries here. Okay. Next is the nickel cadmium storage batteries. Next is what? Nickel cadmium storage battery. So here you can see the nickel cadmium storage battery. So electrode is at the top. Okay, here you can see at the right corner. So electrode is at the top and this is a negative electrode. This is a positive electrode. Then, okay, you have a cathode. Your cathode is there. Then after cathode, there is a separator. Then you have anode. Anode is your cadmium and a separator. So like this is your nickel cadmium storage cell. Now in this, what is your anode? Anode is cadmium and cathode is metal grid containing nickel oxide. Okay. And the electrolyte solution is your KOH solution. So what is the anode reaction? The anode reaction is cadmium plus 2OH minus gives you cadmium oxide plus H2O plus 2 electrons. And nickel oxide plus water plus 2 electrons gives you nickel hydroxide plus 2 OH minus. So the net reaction, so important is net reaction here. Okay. Now your nickel cadmium cell. So when you are comparing this nickel cadmium cell, then lead storage battery, here the nickel cadmium cell, it has a longer life. Okay, it has a longer life than your lead storage battery. But this nickel cadmium storage cell, it is very expensive. Okay, it is the cost is very much more. Okay, the cost is very much high. So when the reaction, okay, is discharged. Okay, how it is discharging is what your cadmium and your nickel oxide is converted into the corresponding oxide, that is cadmium oxide and nickel hydroxide. So again, when you are charging this what anode and your metal grid that is of nickel oxide, so you will get back when you are charging again. So when discharging, you will get cadmium oxide and nickel hydroxide. So where these nickel cadmium cells are used. So these nickel cadmium cells, these are used in camera flashlight. Okay, in the camera's flashlight, what we are making use of? We are making use of the nickel cadmium cell. Is it clear? Yes. So these are the about batteries. So what are batteries? Okay, what are the types of batteries and the examples? So very important from exam point of view. Okay, so nickel dry cell and lead storage battery. So all the batteries you need to know what are the anode, what is the anode, what is the cathode, what is the overall cell reaction. Okay, construction and working. But most important, which is asked during okay in the repeatedly in the exams is lead storage battery and the dry cell. Okay, is it clear up to here? Yes. Okay, so this completes our batteries. Okay, so next is fuel cells. So this fuel cells we'll be doing it in tomorrow's class. Okay, so we are left with a very small part that is about fuel cell. Then the example of fuel cell, that is a hydrogen oxygen fuel cell. Then we are going to see some exam application of electrochemistry. Okay, that is then we are going to see the electrochemical processes, that is rusting and corrosion. Okay, is it clear? Any doubts up to here? Yes, any doubts? So whatever I have been telling, so I want you all to just go through the things. Okay. So tomorrow, I think tomorrow will be the Tomorrow, yes, tomorrow is the last. I am going to explain you about the electrochemistry. Okay, and then after that, we are going to take 2 days for solving the problems on electrochemistry. Okay, so tomorrow last, I'm going to take the fuel cells theory part. Okay, after that, we are going to start with the problem. Is it clear? Yes. Yes, for board, if you are talking about board, only if you do NCERT textbook, it is too much. Okay, for boards I'm talking about. So if you want to concentrate on boards, so NCERT textbook is enough. If you want to practice more CET questions, okay, you want to do something for the competitive point of exam, okay, competitive exam. So that time you have to refer some good books. So you have to refer some good books like MTG, okay. So like that. So you can use MTG. So then you will get some applicative questions. Okay, so that will help you. For boards, if you're talking about boards, NCERT is too much. Okay, if you read thoroughly the textbook also. Okay, so please go through the things whatever I've been telling till now. Okay, so if you have any doubts, you can come to me tomorrow. Fine. So tomorrow, after completing the small theory part of yourself, then we are going to continue with the problem session. Okay, from this, as you all know, from the physical chemistry. Okay, so we have completed 2 chapters. Okay, solution and electrochemistry. So you'll be getting questions. Solutions I have solved. Okay. Now electrochemistry also, we will be solving some questions. So what type of questions are asked during exam? So please make practice. Okay, you keep on practicing. Okay, so in problems, you can score well. Fine. Okay, so by this, I would like to end the session. Okay, so we'll meet in tomorrow's class. Okay, fine. So thank you, dear students. We'll meet tomorrow.